Perfect. How are you doing today, Akash?
Yeah, I'm doing well. I'm doing well.
Great, wonderful. So, Akash, I'll leave you with our viewers. We have a lot to cover, and I think you're the best person to take that forward. So, I'll leave you with our viewers, and all the best.
Thank you. All right. Hello, everyone. Firstly, I would like to say thanks to, I guess, Nivedita for warming up the audience with her amazing talk on mobile accessibility. I worked with accessibility on the web, and it was my first foray or view into how accessibility works on native devices. So it was nice to learn more about that. And yeah, my name is Akash Joshi. You can find me as the writing dev on most social media platforms. And today we are going to be talking about revisiting React rendering. So I wouldn't, I renamed my talk to revisiting React rendering because I don't feel as comfortable talking about the performance side of React. But I've done some research recently around how React rendering happens and how things work internally, just to be better at my job and to help with my side projects and stuff like that. About what I do, I am a platform engineer at Hash. Basically, if you go to hash.ai, this is what we do. And if you check out our careers page, and if you're looking for a new role, new senior role right now, be sure to check the We Are Hiring tab right over here. So, anyways, back to the talk. Back to the talk. Yeah, as I said, I've been recently experimenting and trying to find information online about how React rendering works and what actually happens inside of React. So, and yeah, about the difficulty of this talk, it is going to be very straightforward, and I've tried to keep it as beginner friendly as possible. So, advanced folks, feel free to correct my mistakes wherever you can, because that will help me be better at my work as well. So, yeah, the first step is about React rendering itself. How does rendering happen? Well, firstly, you write your code in JSX, as you all know, which is basically an XML-like syntax in which you can pass objects and functions inside of the attributes, so that any uh, child tags. I guess we use the parent-child terminology in React, so you know what I'm talking about. But any child components can use the references from its parents, and basically we are calling them props inside of React. So yeah, I've got an example like component on screen right now. So I mean, most of you might be familiar with something like this. This is a counter component, and I have defined a child component here, which takes up count prop from its parent, and the parent also has a button which modifies the state as needed. So for now, we won't get into the depths of it. We had a look at what JSX looks like, and then this JSX is converted into bundled React code, which is basically create element function calls and other things like that via big tools like Webpack and then Webpack plugins like Babel. So for example, we can input the code that we just wrote over here. And once we do that on the right hand side, what is this? This is the Babel playground. You can try putting in any of your JSX files in here to see what the end product looks like. So this is the actual code that your browser sees, and based on the functions present here, function calls are made to the React library, and based on that, then React generates your virtual DOM. So virtual DOM is basically a representation of the JSX that you have provided, and why React holds a virtual DOM is to avoid making changes to the real DOM as much as possible, because changes to the real DOM are expensive, since it results in a paint on screen, which is a hardware intensive process. So yeah, we have a virtual DOM, which we'll have a look at soon, and then the real DOM is generated from it. And these two phases are independent from each other. So the first phase where the virtual DOM is generated is called the render phase, and we generally have more renders than commits. The commit phase is basically when React goes through the virtual DOM tree, and for each render, you will have a new representation of what the UI should look like via the elements that you are providing to it, since React is a declarative language. And internally, React decides which DOM nodes it needs to update through a process known as reconciliation. And then it finally goes and updates it in the actual commit phase. So generally, you have more renders than commits, and we are going to go into an example of that. So uh, yeah, let's have a look again at the previous code example that I had shown. Uh, Again, to reiterate, we have a state for a count, and then we have a button which increases the count, and then a counter component which is just responsible for displaying this for now. So why have I created this? Let's go into the page and just have a look at the actual component ones. So yeah, so the wait, what did I do just now? Yeah. So the important bit here is basically this one. I am creating, instead of directly writing the JSX in the return part of the function, I am defining it as an element, and then I'm console logging this element just so that we can see how the virtual DOM is being represented inside of React. And you can do this with any component that you have. Just console log the JSX that you're returning instead of directly returning, and then you can see what it looks like. So, all right, here I have the actual, yeah, I've opened the console and I can see what the elements internally look like. So this is on first render, so I guess Chrome doesn't really know what to do with it, but I'll increment this once, and every time I click on increment, the counter here increases its number based on the internal state in React, and then a new element is also generated in the render phase. So again, we talked about render phase and commit phase. So this is uh, whenever a render occurs, the console log part of the code is running, because it is trying to parse this component and trying to generate a new virtual DOM from it. And then the commit phase is the phase when the actual UI gets updated. So for each render phase, we are getting a representation of the virtual DOM object for the counter that we have console logged. And here we can see all of the properties that are present on the React element. If you look at the TypeScript type for it, you'll see something similar as well. So type of, which is basically React element, and then the key, we aren't passing any key here right now, and we'll have a look at what the key attribute really means. And then props, inside of this, the props being passed are basically the children. As you know that these, I mean, anything that you define inside of your JSX automatically becomes part of the children property, and you can access it generally via props.children. So this is what is being passed down here. And then other properties like ref and type, which you might already be aware of. So ref is kind of like the reference to the DOM node. I guess we can go into that a little bit as well. And then type is basically what type of DOM node is being generated. So in this case, since this is a dev node, the type that create React element, React.create element is generating is dev. And yeah, as we said that, I mean, what we saw here was basically the render phase and commit phase being the same in amount. But let's see an example where there can be more renders than commits. So for that, firstly, let's inspect element this and try to see what a commit looks like. So Chrome and Firefox and other web inspectors are really helpful in that whenever you make a DOM change, they helpfully highlight the change that has been made. So if you just click on increment a bunch of times, you'll see that this number is being incremented. So Chrome is helpful for that right now. And yeah, to show an example of renders being made, but the commits not being made to the UI, I can just remove the count from element, like the count, I guess variable we can say for now. And then what we see is that whenever I click on counter, that doesn't really cause any commits because there is no UI change to be made. React already knows that, so it won't make any commits. But internally, it is still creating new renders, new versions of the virtual DOM for each uh, state change that we are creating. And to test that, we can just click on increment a bunch of times, and then the console log that we have written in your child component, it gets updated. So this is a pretty good example of how the React phase and the commit phase work. And then, I mean, in your app, you can also try this out and see how things might be functioning internally. So yeah, that was about React rendering. Next up, we have optimizing lists. Now, this is somewhat interesting because I think this and the next slide are good. I mean, a good reiteration for some of the more advanced folks, and for the juniors, like they might be learning something new from this part as well. So if we go to a React element, we saw the key prop here, and yeah, I guess you might be curious, what does it actually do? Key is basically a way for developers to help React uniquely identify each DOM node. So mostly React tries to implicitly make changes and updates to the DOM nodes on screen. But sometimes for things like arrays, where you have an internal description of what the array looks like in a state variable somewhere, and the DOM nodes might not exactly map to what that array state looks like, it is helpful to pass in the key variable so React can identify each of the internal state of the DOM nodes with the actual DOM nodes on screen. And to test this out, what we are going to do right now is write an array from scratch, and I mean basically like try to render an array from scratch, and based on that, we'll see how React kind of breaks down when we pass down the wrong key or an unstable key, and what we can do to fix that. So yeah, hopefully I didn't hype that much, that up too much, because it's a really simple test that you can try it out yourself. So yeah, I'm using Next.js here, so I have to make a default export at the top. So I'll just write something out right now. Firstly, let's just say I write out something like array test, and let's check if that gets rendered on screen right now. So yep, we have this getting rendered. Now we'll go into writing our actual array code and see what happens. So I'll define an array here and have an initial state generated for it. So just a second. I'm on Windows right now, so the auto import system isn't that great. Yeah, useState. Yep, thank you. And so yeah, we need to render something on screen with the array that we have. So we need some data for that. I'll write a very simple function, get array, which will generate an array, and then generate an array, let's say of size 5, and then returns random elements inside of it. So it will do something like, I guess, math.random star 100. So we'll get elements from 0 to 100, and then I'll add dot to fixed 0 to make this to remove the decimal points from it, and then we can check the return type of to fixed, which is string. We need numbers here. I mean, we don't really need numbers, but since these are like numbers which we are generating, it would be helpful to have the correct return type on it. So I'll just use parseInt on this to convert this into integers. And now, let's say we generate, okay, I might have accidentally clicked on something else, but yeah. Yeah, as an initial state, it will generate the array from get array, and then let's say we just print that on screen for now. So array.map element, and I need to display something with the internal state of the actual element as well. So I'll create a new function, a new component for the individual elements, which I'll describe here. And then for now, let's just say that we are passing in some data as element here and displaying it right over here. So yeah, this will do that. So now looks straightforward till now. We have a function which generates arrays for us. We have an array state in here, and we have a simple component which just displays whatever element we are passing to it. So I'll call this component here now, element, and element equals to element. Okay, too many elements in here, but I guess that's okay. And then ESLint, of course, complains to us that we need to pass in the key property to an array. And this is the unstable version. So for now, I'll be passing the index of the array. I don't recommend doing that for reasons we'll soon be coming to. And now if I save it, okay, so I'm getting nan. This is always interesting, debugging problems while giving the talk. So okay, it's still throwing nan. All right, no worries, we can solve this. Dot fill new array 5 dot fill dot map. Is there something that I've done wrong here? I'm sure there's a pretty okay, yeah. Wait, I do have I always create separate pages for the actual, I mean, what the final thing should look like, because things like these end up happening. So no worries about that. I'll just pick that function from here and then paste it in here. And yeah, all right. Okay, let's just ignore the last 2-3 minutes right now. And yeah, so we are generating a random array and then displaying it here. So let's say that we are trying to add more elements more elements to this array. But since we are trying to display a non-regular example, irregular example, let's add elements at the start of the array instead of at the end of it. So I'll add a simple like button, let's say add elements, and this will add elements at the end. So on click, I will do something like set array and generate a new array and then spread over it. So generate random array, spread over it, and then spread over the existing array that we have. So this should add elements to the top of the array that we are seeing. So now when I click on add elements, okay, it's still generating new elements. It looks fine, right? But don't worry, we'll break this soon. Now, instead of passing the element down directly, let's say that I have an internal state, something like, again, the good old counter example. Let's say I am displaying an array of counters instead of, just displaying using the elements directly. I'll pick up count from here, paste it in here, and now I save this. And yeah, this looks fine for now, but once I refresh this, all right, Next is taking its good time. Okay, so now if I click on add elements, whoa, what happened there? The same array got duplicated. The array that we saw at the first time, it got duplicated because React doesn't know which state to pass to which array element, because we have an internal state that we are defining here, and then we are mapping over it to the actual components. But which array element maps to which component? We are passing the wrong, an unstable key here. So React doesn't know how to identify that. And yeah, if we keep on clicking on add elements, it just duplicates the same array instead of actually displaying the correct elements. So one way to fix it, the right way to fix it is to pass unique keys. And let's say that for now, since we are generating random elements anyways, we pass that in, and if we do that, does that fix it? So all right, so looks like that fixed it. So yeah, this is a very good example of why you should be passing in unique keys to your elements. Now if I click on add element here, we can see that all of the elements are being generated correctly. So yeah, I guess I'll just leave it at that for now. And if anyone has any questions or any complaints about this, please do add them at the end. So next up, let's look at remounting components. Another good use case for using keys is basically remounting any existing components that you might have. And this is something which unfortunately I didn't know at the start of my career. So I was writing uh, I, I was like handwriting code for resetting forms and things like that. So for now, let's just reuse the existing component that we have on screen. But for now, I'll just remove the array and replace it with a form. So all right, we are displaying this, so we can remove that. Let's say that we have a form component, which is rendering a form on screen for us, and it's like a pretty complex form which has, let's say, a text input. Then we are taking, let's say, the user's phone number, so we have input type equal to tally here. And then uh, let's say we also are taking we are asking them to sign off on the terms and conditions, so we have a checkbox here. And then finally the user can go and submit this form, so submit on here. And then to prevent any re-renders, refreshes, I'll just add a good old event.prevent default in here. And yeah, let's try rendering that form in here now. So we'll replace this to form test. Wait. Yeah. So yeah, we have this form. We don't need this button as well. I'll just remove the on-click element from this and add reset form in here, and we'll see how this works. So I have some elements which I'm input elements which I'm adding data to, and on clicking submit, I will have to manually write the code which resets the internal state. Or the easier way, which all of you already know of, is like you can remount the component. But instead of using something like conditionally rendering two versions of the component or doing something crazy like that, there is a very simple way of causing components to remount. The senior folks already know what I'm going to be talking about, and that is basically using key again. So when you pass in a new key to a virtual DOM node or a React component, then React will think, we are basically telling React that that is a new component and that you should unmount the old component and then remount the new one. So I guess we can call this count or key ID or whatever you want to. I'll just call this count for now. And then on click on the reset button, I'll simply increment the count that we have. Cool, nice. So yeah, we are rendering this, and if I enter something here, I'm still not doing anything on submit, but let's ignore that part for now. And let's just focus on reset form. So when I click on reset form, magic, all of that data is vanished. And that's because the key for that value, key for the component changed. And if you are not yet convinced that the old component is unmounted and new one gets remounted, let's have a look at useEffect and try console logging something to the page. So on whenever useEffect runs in for the first time, let's say that I run mount, and whenever the cleanup function is run, I run unmount. And Okay, cleanup is not defined. Yep, I need to update my keyboard shortcuts, I guess. So yeah, we have this on screen. And am I on the right page? Yeah, I'm on the right page. So if I refresh this, then this component mounts for the first time. And if I make any changes here, submit, nothing. And when I click on reset, then the old component gets unmounted and then the new component mounts in. So that's what causes the state refresh that we are seeing here. And yeah, that brings me to the end of this slide. I think we have virtualized lists, which is another good way of reducing the number of commits that you might be causing. So virtualized list is basically a list in which instead of rendering all of the virtual DOM nodes as DOM nodes, what you're doing is you are rendering a subset of the DOM nodes. I mean, a subset of the array elements that you have on screen. And I mean, this is done based on where the current user is. So you use something called the intersection observer, which helps you in doing that. And then you add padding to both sides of your parent container to simulate an infinitely scrolling list. So yeah, virtualized components. I mean, virtualized lists. Sorry, I suggest doing more research on that. I won't get into more detail about that because it's a talk title on its own. And yeah, so that was mostly about the commit phase of React rendering. And now let's focus a little bit on the render side. So yeah, nowadays we all use useState and useEffect, and why they exist. A boring answer for that is because functional components exist and they need to be more powerful. But a more interesting answer is that class components were really, I mean, the way we were doing things in class components wasn't really that great. And we'll go into more details of why that is. So firstly, I guess this won't make a lot of sense if you haven't looked at class components before, but you know that classes have constructors. So I guess that helps you in classes have constructors and then functions that you decide inside of it. So class components in React use those to basically take input from the user and then generate a VDOM and then the DOM node and all of that good stuff. So how we handled state initially was we had this dot state, I mean a state variable defined inside of the class, and then whenever we ran the constructor, that is when initialization was done. So basically this dot state is equal to some state. And another thing that you might notice is that instead of having multiple state variables like we can define in functional components via the use state hook, here we only have one state, and then that state is a combination of all the state that your component holds. So it can become very complex very quickly. So here we just have a counter, but imagine you are storing user IDs, then user details and all of that inside of this component. So it can become very complex. And on top of that, we just had one set state function. So all of this is in the React docs. I guess I don't really have to go into the depths of it, but basically set state works kind of like the same like our current set state function. You pass an updater to it, and then it has a callback for stuff that you can do whenever set state runs. So yeah, that's how state used to work. Now going into effects. By effects, I basically mean network calls or any GraphQL subscriptions or WebSocket subscriptions or anything which you are trying to do outside of the context of your React app. How it used to happen in the olden times, pre 2018, I guess. So yeah, we have a few life cycle functions here, and basically what these did was like I think the two most important ones for us right now are component did mount and component did update. So component did mount, it executes when the React component gets mounted onto the DOM, and component did update, it ran whenever either the props changed or the state changes. And I might be wrong here because I haven't worked extensively with class components, so feel free to correct me. So that's how it generally worked. And in component dot, so where API calls and other effects happened was generally in component.update. In this case, like this is from the official docs. So the recommendation generally is that you check for the props, and if the value of the props changes, or I mean the value of the state might change, then make the function call. So this might look, I mean, if you worked with useEffect, this might look kind of similar to that, but you kind of see what the downside here is. This is creating an implicit dependency between props or state and some effects or function calls inside of your code. And implicit dependencies are bad because they make the code more difficult to read for newcomers. And on top of that, it is also more difficult for parsers like, uh, let's say, ESLint to know what's happening inside of your component. So just for that reason, like useState and useEffect are a big, uh, step up from how things used to be done, because you know that if you have, I mean, I'll just define a dummy component here. Why not? So let's say we have something like display user data or something, and then that component takes in the state of user ID. And let's say that, we are just displaying something like, I guess, user time here. So you know that if you define a use effect and subscribe it to the user ID by adding user ID to the dependency ID, then you can reliably, okay, what does that do? Yeah, so you can reliably make function calls or any effects from inside this use effect. And you know, like, I don't know, I'll just pass on the user ID for some reason. So yeah, you know that any uh, any code or effect that you have defined inside of use effect, it will only run when its dependency array changes. So this is more explicit, I mean, which makes it more readable both for machines and for humans. So there's something you can use on top of that to help in the readability and the debuggability a little more, which is basically like rules of hooks. You might have heard of it, but this is just a suggestion that I'm making in case you don't already know about it. So yeah, rules of hooks. There are some rules which exist, but you can use an ESLint plugin to help you in, I guess, doing it automatically for you, or at least pointing out whenever you are doing things wrong. And yeah, I guess we'll quickly go through this, but basically reducing state renders. We'll see how rendering in functional components happen and how you can kind of optimize state renders here. So I have defined an example component for this already because I know that it might, I mean, it might be a little later in the talk that when this part comes up. So I'll try to go here, state cascade. So yeah, basically I've defined kind of like a tree of various React DOM nodes. Uh, this is the generic counter example again, but it's helpful for doing that because, I mean, we are already familiar with the example and it quickly, I mean, there is no need to understand new code. It's all old code and we can get to the meat of the problem. So right now we are trying to debug how React renders occur, kind of like the first piece of code that we were looking at. So I have the top level page component here, which has a button defined, an internal state, and then the first child component. So I am passing the value of count from the parent to the first child. And then what the first child is doing is that it's logging rendered and it is rendering the value of count in here. And then it is also rendering a different component called second child. And then we are logging second render inside of it. So what do you expect the behavior of this component to be like? Since we are time limited, I won't give you time to think about it. But what this will do is basically every time the state and the parent component changes, all of its children are re-rendered. That's because React doesn't know where we are using the state inside of the components. And components might also have some implicit dependency to the state that React can't know about. So it's much more safer to re-render everything than try to optimize inside of this. So it's up to the developer to do the optimizations themselves, and we are going to have a look at it. So firstly, when I refresh this page, we can see rendered, which is basically the first component, and the second render, which is basically the second component. Now, when I click increment, it renders both the first child and then the second child as well. And as many times as I click increment, we can see that both of the components are being re-rendered. Now, how do I optimize this? Well, the most straightforward way is to memoize your second child component. Now, I guess if I have time, I might go into what memoization means and how we can implement our own memoization function. But I'll just say memoize child, react.memo, second child. And if we render the memoized child inside here instead of the original component that we had, and we check the console again, we'll see that second render only runs once. And whenever we are clicking increment again, it is not re-rendering the second child, but only rendering the first one. So why is that? React.memo is basically a higher order component. So higher order component means that React.memo itself is a component which accepts a different component as its parameter, and it is returning a memoized version of that component. So again, I guess I won't go into details of memoization, what memoization means, but in this case, what that means is that based on the props which are being passed to second child, if the props remain the same, then it will always remain, I mean, it will always return the same version of the component. So in this case, since we aren't passing any props to memoize child, no props are being updated, hence no re-rendering occurs. However, if we pass in the dynamic prop that we have here into this component, I mean into the memoized version of the original component, and then we click on increment, we'll see that the second component starts re-rendering again, and that's because we are changing the value of count, which means that its props are changing, which means that it will cause the component to re-render. Now, if we replace this with a static value, for example, if we are just passing 1 to it, and if we refresh the page and try to click on increment a bunch of times, then that doesn't re-render the second component because it isn't really, I mean, the props aren't really changing. So yeah, that's how we can prevent re-renders. Now, I guess I can go into things like what does memoization actually mean, but Digvij, I'm not sure if I have the time right now. Uh,
Oh, we're a little above schedule now, so I think we can just
yeah,
probably quickly wrap it up.
yeah, no worries. So, I was kind of aware that we were going to go over time anyways. So I have a small resources page here. You can look at what useref is. So useref helps you in preventing re-renders, not in the way that you expect. Basically, useref is for storing mutable values, and it doesn't cause further re-renders, but state changes cause re-renders again and again. Then you have memoization, which I briefly talked about, but you can go into more details by Googling that. Like people way smarter than me have written articles about it. And then you have use callback and use memo. You can either check them out in the React talks or anywhere else as well. Yeah, one I guess fun fact that I would like to talk about here is basically that any memoized value that you have, it only React only holds one previous state for that. So it doesn't do any caching for you. It only helps you in prevent re-rendering. So you can't get, I mean, if you are expecting it to give you like a lot of performance improvement, then probably you need to look at the actual code that you have written. So yeah, I guess that's it about me. Thank you. You can find me on Twitter at the Writing Dev, or subscribe to my newsletter or blog at thewriting.dev. And I'm currently exploring new opportunities. So if you have one, feel free to reach out to me. So yeah, thank you.